Okay, so hello everyone, welcome. Can you hear me?
Yes, sir.
Okay, just we are waiting 1 minute, then we'll start. Okay, so we'll start today's session. So basically today was second day, and I hope all of you already get the all of materials who already joined the Google Classroom. Okay, so let's go continue. So basically today discuss about that some advanced topic on remote sensing and also apply the Google Earth Engine, mainly JavaScript and Python. Both of programming language we try to apply, and then further we check. Okay, and after completing the 3 hours live training program, then we talk about the problem solving class. So previous class I already give some assignment. So if you face any problem or any confusion for the previous class, then we also talk about that problem solving for 1 hours after completing the 3 hours live training program. Okay, so let me share my screen. Okay, can you see my screen? Is it visible? Okay, thank you. So let's go. Okay, so basically today's session I discuss about that how we can easily filtering and displaying the satellite images, mainly Landsat or Sentinel or Modis. So this type of satellite imagery, how we can easily filter and displaying, and then how we can easily use the satellite composite. So different types of composite, median composite, then mosaic composite. So this type of mosaic, how we can easily create, we also discuss about that, and how we can easily create the band combination. So different types of band combination we also discuss about that, and how to export the satellite imagery from Google Earth Engine. We also discuss about that. And then how to import, filter, reduce, clip, and display the raster data in Google Earth Engine. As well as we also discuss about the time series chart. Okay, how we can easily create the time series chart using ready-made dataset. So what is the ready-made dataset? Further I also explain. Basically we find out the two types data, ready-made data and unready-made data. So for the ready-made data we need to apply the another approach, and for the unready-made data we need to apply the another approach. Okay, so I will try to explain both of things, then you can easily get the idea how we can easily make the time series chart using the different types of dataset in Google Earth Engine. And how to export any shapefile, we also discuss about that, as well as we also discuss about that annual image composite. Okay, suppose you want to create the annual image composite, suppose from 1990 to 2024, all of year you need to create the image composite. So it's very necessary when you work for the land use land cover change analysis for the different time period, or NDVI change analysis annually. So then it also help you. So that's we also discuss about that. So let's go try to discuss all of topic step by step. And after completing this today's session, then we talk about the problem solving class for the previous classes. So let's go. Let me share my slide. Just so we already know Google Earth Engine is a totally cloud-based platform, and every cloud-based platform have a own server. Okay, so every cloud-based platform have a own server, and everything will be controlled from a server. Okay, suppose we can easily get any kinds of data set. This type of data we can easily access from Google Earth Engine server. Okay, and it's called as a Earth Engine public data catalog. Okay, from the Earth Engine public data catalog we can easily access all of remotely sensed data which are freely available. Okay, such as Landsat, Sentinel, MODIS, different types of train data, different types of land cover data, different types of atmospheric data. And this type of data mainly always we find out the update data, okay, in the Earth Engine public data catalog. So this is the another benefit to use in Google Earth Engine. So basically when you are using the Google Earth Engine, you don't need to download any kinds of satellite imagery. We can easily access all of satellite imagery from Google Earth Engine public data catalog. Okay, and further we can also use it, and this is the link about the dataset. So you can simply visit this link, then you can easily access all of publicly available dataset in Google Earth Engine, and further you can easily use it. Okay, so here I already, or if you want, simply go to the code editor. From the code editor just click on the browse data catalog, so then it automatically open the all of Earth Engine public data catalog. So here you can see all of dataset. Mainly we find out here the surface temperature data, then climate data, also you can see the atmospheric data, weather data. So different types of imagery such as Landsat, Sentinel, also you can see the MODIS, high resolution imagery, different types of train data, land cover data, cropland data. So it provides a lot of data set we can easily find out. When I click on the Landsat, so then I can get all of Landsat data such as Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. So all of that we can easily get. When I click on the Sentinel, so it provides me all of Sentinel data, Sentinel 1 data, Sentinel 2 data, then Sentinel 3 data, Sentinel 5P data. So all of data set we can easily access from here, as well as also you can see the MODIS. So it provides a lot of MODIS product for the different. So you can see this the traffic data. Okay, different types of MODIS data we can easily access from here. Okay, so now how I can easily filter the Landsat data. So basically Landsat data we find out the different types of time period. You can see Landsat 9 is available between this time period, Landsat 8 is available between this time period, Landsat 7, also Landsat 5, Landsat 4, Landsat 1 to 5 available between this time period. So now how I can filter this Landsat imagery using Google Earth Engine. So let me open my slide. So when you filter the land satellite imagery, mainly Landsat or Sentinel, So when you filter Landsat or Sentinel or any satellite imagery, this filtering process is different on some factor. Okay, suppose first factor is your region of interest. Basically, which area you need this satellite image. Suppose I need the satellite image for Dhaka city. So this Dhaka city, this region is one kind of factor for filtering. Another factor is that image metadata or image properties. Suppose I need the image less than 1% cloud cover. Okay, so this is the one kind of factor for filtering. And third factor is that a specific time period. Suppose I need this image in year of 2017. I need this image in year of 2017 month of suppose summer season or rainy season or any specific time period. So when you filter any satellite imagery, it can be Landsat, Sentinel or MODIS, then just it depend on three factor all time for any satellite imagery. First factor is region of interest, mainly where you need the image. Second factor, image properties, image metadata. Suppose I need only for those images which image will be not more than 1% cloud cover. So this is my second factor. Third factor is your image specific time frame or time period. Suppose I need the image in year of 2017. I need the image in year of 2020 month of January. Or I need the image in year of 2024 summer season or rainy season or any specific time period. So when you filter your satellite image, just remember these three factor. Just use these three factor and then we can easily filter our image collection. So let's go practical example. Then you can get more better idea. So first of all, suppose I want to work with Landsat and suppose I want to work for Landsat 8. Okay, so here you can see in the Landsat 8 we find out that surface reflectance satellite imagery, top of atmospheric reflectance satellite imagery and raw imagery. So three different types of reflectance we find out in here. So basically when you work with land use land cover classification or land surface temperature monitoring, then we are using here the surface reflectance satellite imagery. But when you work with different types of indices such as NDVI, NDWI, SAVI or different types of indices, then you also use at the top of atmosphere reflectance. Okay, so you can simply search on the Google, then you also get a lot of idea, mainly theoretical part about the surface reflectance and top of atmosphere. So simply search on the Google, you can get a lot of things about that. But when you filter this type of image collection, we process the same. Suppose Landsat 8, Landsat 9, Landsat 7, Landsat 5, all of are the same approach. Okay, so in this case surface reflectance or top of atmosphere is also same approach. Okay, when you filter this type of image collection, suppose I want to work for top of atmosphere reflectance, just I click on here. So you also try further, you also try for surface reflectance. Now I show you for that top of atmosphere, same process you also apply for the surface reflectance and then further filter. I also give some assignment regarding this topic also. So just click on the top of atmosphere. So now here you can get some information about that Landsat 8 top of atmosphere reflectance data. So this data set is available this time period, and this dataset provider is the USGS and Google, and this is the unique ID of this dataset. Okay, unique ID mainly this is the directory. Suppose this is the directory of Landsat 8 collection 2 tier 1 top of atmosphere reflectance TOA. Okay, so it's called the directory. Okay, so in this directory this full image collection is stored. Okay, and we find out all of description about this data set. We can find out all of band. Okay, so different types of band: coastal, aerosol, blue, green, red, near infrared, short wave infrared 1, short wave 2, panchromatic band. So different types of band. We find out the different types of image properties or image metadata information. So now this is my data set. So this data set I want to import in my code editor. So this is my code editor. So how I can import this data set? So importing this data set, you just simply copy this Earth Engine snippet. Just copy this snippet and then paste in the code editor. Just paste here. Okay, so now you can see how we find out that ee.image collection, And previous class, I already discussed about the Earth Engine data types. Mainly we find out the 5 types of data. Okay, so image collection is one kind of Earth Engine data type. This is the image collection, and this image collection mainly Landsat 8, collection 2, tier 1, top of atmosphere reflectance. Basically this is a directory. Okay, so this directory, it stored the full image collection between the time period 2013 to 2025. All of emails stored in this directory, in this snippet. Okay, so now I simply copy and paste here. Further, I just give a variable name. You can put any name as a variable. We already know about that, how we can easily define the variable in JavaScript programming. Just use the var keyword. After that, you can put any name as a variable. Okay, suppose I put the name is that L8. You can put any name as a variable, then put the equal sign. So now this full image collection is stored in this variable L8. Okay, so now this full image collection is stored in this variable L8, like as a folder. Suppose this folder, I just stored this full image collection. Okay, so now further I want to check how many images are available in my collection. Okay, so for that, as a beginners, I don't know what the function I need to use. So further, simply you can go to the docs tab and search here image collection. So now here you can see image collection in the heading, and when I click on the heading, I can get some sub function of image collection. You can see different types of sub function. You can easily find out in here. So here you can see one function, this function called as a size function. Okay, size function. So just I click on here, it show the return the number of the element in the collection. Suppose in this image collection, how much image or how much element are available, I want to check it. So for that, I need to use the size function. Okay, and size function is available in the image collection section. You can see this is the image collection section. So that's why this size function is only work for image collection. This size function you cannot use in the image. Suppose I have a data type in image, so I just apply the size function in the image, so then it show that size is not a function. Okay, so now I can just print the L8 and use here the size function. Okay, just I simply use the size function. So now this size function computed how much images are available or how much elements are available in this L8. So let's go try to run the code. So now it's computing this number, total number of image collection for the whole world between the time period 2013 to 2025. Oh, find out this type of number. Here you can see very large number of image collection, more than 1 million images we find out. Okay, so this is a large number of image collection stored in this variable. So now this result for the whole world. Okay, but I don't need for the whole world. I need for it a specific boundary. I need it suppose for the Dhaka city or a specific any boundary shape file. We can simply work with that. Or if you want, you can simply draw a, suppose I need the image for this boundary, for this, just simply draw your study area look like this way. Or if you want, you can simply digitize your boundary area and also work with that. But in this case, I simply import my boundary shape file because I already import the boundary shape file, and previous class we already discussed about that. So just let me import a boundary shape file. Suppose just I import this Dhaka city boundary. Okay, so it show imported and it show the table as a variable. I put the name suppose as a RY. Okay, so this is my study area. So now if I just display my study area, we already know about that. Just add a layer of RY and also focus the center of this boundary shape file. Okay, just use at the RY. I put the zoom level 10 and click run. So now we can easily find out this is my study area. So now we find out the very large number of image collection for the whole world, but I don't need for the whole world image collection. I need only for those images which images are available in my study area. Okay, so now how I can filter. So now if you check the docs tab, here we find out another function. This function called the filter bounce function. Okay, so you can see the filter bounce function we need to use in here. So it's mainly shortcut to filter a collection by intersection with geometry. So in this case, I have a already large number of image collection. So this image collection, I just simply intersection with the geometry my boundary shape file, and this variable name is ROI. Okay, so then we have to use the filter bounce function. You can see what is the argument mainly geometry mainly your boundary, your polygon. Okay, so when I use this function, what happened? It filter a collection by intersection with geometry. Suppose I have a total large number of image collection. So this large number of image collection, but I need only for this boundary, how much image is available for this Dhaka city boundary. So for that we just use here the filter bounce function. So let's go try to use it. For that, just take a variable. Suppose I put the variable name, suppose filter region. You can put any name as a variable, filter region, and I call the L8. Okay, L8, and call this filter bounce function. Okay, filter bounce with my geometry. So in this case, my geometry is my shapefile boundary. Okay, this is my area of interest. So just I put here the ROI because I need the image only for this boundary. So now let's check how much images are available only for this boundary. So this thing just stored in this variable. Okay, so when I just filter bounce function, so just it intersection with the whole image collection for my study area, mainly Dhaka city boundary, and it stored the all of image only for the Dhaka city boundary. So let's go try to print the how much image is available. Just use here print function and call the filter region and use here the size function and further run it. We find out that 465 image collection are available in my Dhaka city boundary. Okay, and what is the time duration? Time duration, mainly this time duration 2013 to 2025. Okay, and this 465 image collection including all of cloudy imagery. Okay, but I want to filter the image properties or image metadata. I want to filter. Suppose from these 465 images, I need only for those images which image will be not more than 1% cloud cover. I just need only for those images which image will be not more than 1% cloud cover. So let's go try to use it. So for filtering image metadata, we have to use this function filter metadata. So here you can see filter metadata function. So in this case, shortcut to filter a collection by metadata or image properties. Suppose I need the image less than 1% cloud cover. So here you can see what is the argument: name, operator, and value. Name mainly image properties name. If you check the image properties, here you can see different types of image properties name: cloud cover land, cloud collection category. Okay, so different types of property you can easily find out in here, as well as mainly operator mainly less than or greater than, and value suppose 1 to 3. So in this case we have to use it, and from these 465 images I need only for those images which image will be not more than 1% cloud cover. So let's go try to do it. So for that, just take a new variable. Suppose I put the variable name is that filter, suppose filter metadata. Okay, and now 465, this image is stored in this variable filter region, just I copy and use here, and then we are just apply the function filter metadata. Okay, in the filter metadata we find out the three argument. First argument is name, name mainly image properties. Where we find out the image properties? We find out in here in the image information. You can see image properties. I want to use suppose cloud cover, just copy and then paste here, and it's a string, must use here the quotation, and then operator, I put the operator suppose less than, suppose set the value for 1. So now this variable is stored only for those image which image will be not more than 1% cloud cover. So let's check how much image is less than 1% cloud cover. Just use the print and call the filter metadata, just copy and use here the size function. So now run the code. We find out the 69 images. Okay, this 69 images is less than 1% cloud cover. Sometime when you work with suppose coastal area or river bank, then you don't find out the less than 1% image, because if there is no image less than 1%, then we find out the totally 0. Okay, when I find out the 0, it means that less than 1% image is not available for my study area. Then you need to increase the cloud cover level. Suppose check for 5% or check for 10%. Okay, suppose in this case if I just use the less than 10%, you can see it also increase my image collection. We find out that 156 image collection less than 10%. Okay, so when you work with mainly coastal area or river bank or any place where all time cloud formation, then we don't find out the less than 1% cloud cover. Okay, because there is no image less than 1% cloud cover. So for that you need to increase the cloud cover level. But in Dhaka city we can easily find out the less than 1%. Just use the less than 1%. You find out that 69 image collection is available for the less than 1%. And what is the time duration? This is the time duration 2013 to 2025. Okay, this whole time period we find out that total 69 image collection for that less than 1% cloud cover. But I don't need for the whole time period. Suppose I need this for a specific time period. Okay, a specific time period. So for that we have to use this function filter date function. You can see shortcut we have filtered a collection by a date range. Suppose I just put the year of 2021 or 24 or month of January or summer season, rainy season. Just simply define your time range, a specific time range. So let's go, we try to use it. Just take a variable, suppose filter date, and I simply call the filter metadata because this 69 image is stored in this variable filter metadata. Just I copy and paste, and then use here filter date function and define the time period. Suppose 2024 1st January from, I take the 1 year, suppose 2024 24 or December 31. So now let's check how much image is available in this year for Dhaka city boundary. Just put here the print and call the filter date variable, and further use here the size function. Okay, and run the code. We find out that only 4 images. Okay, so only 4 images is available for this study area, and this 4 images is less than 1% cloud covered, and this 4 images is available between this time period. Okay, and this 4 images is also available for my Dhaka city boundary. So you can see, first of all I find out the very large number of image collection. So this image collection I filter for my study area, then I filter using the image metadata, suppose less than 1% cloud cover, then filter for a specific time period. So this is the process for filtering a image collection for your specific boundary, for a specific time period, for a specific, use the specific metadata. Okay, so basically in this case you can see filter bounds function, filter metadata function, and filter date function. So filter bounds function, you just remember that where you need this image. Okay, suppose where you need the image, just your study area define. Then filter metadata function, basically how, suppose I need the image less than 1% cloud cover, and then filter date function. So basically it remembered that when you need this image, so basically where, how, and when. Just you remember the three things. Where mainly we need to use the filter bounds function. Why do you need the image? I need the image for the Dhaka city ROI, because Dhaka city is stored the ROI. Then how, suppose I need the less than 1% cloud cover, so I put here the cloud cover less than 1%. And when, suppose I need this image this time period. So now we find out that only for the 4 images is available after filtering. So first of all, we find out the large number of image collection for the whole world. Then I filter it for my specific boundary. Then use the specific property, suppose less than 1% cloud cover. Then filter for a specific time period. So we find out total 4 images or 4 scene. So further, if I want to get the more information about this 4 scene, suppose just I call the filter date and then print. So now it provides me all of information about this 4 scene or 4 image collection. We find out. Just click on here, you can see type is the image collection. Okay, and if you check the feature, we find out the only for the 4 imagery. You can see the image, just click on, you can see the type is the image. Okay, so this is the ID. Okay, we can get all of information, basically properties, you can see the cloud cover level. Okay, also you can see all of information for this time imagery. Also you can see image acquisition time period. Okay, all of information you can easily get from here. So now suppose I want to display this image, display the single date image. So I want to use, suppose I want to display this image this time period, suppose this image I want to display. So for that, just copy this ID. You can see this the ID. Just copy this ID. Okay, let me just copy, then I increase it. So just copy this ID. And further, it's an image. You can see it's an image. Okay, image. Type is the image, not collection. So for that, just take a variable. Suppose image. You can put in a name as a variable and apply ee.image and put this ID. Okay. So now this variable is stored only for this image. Which image acquisition time, you can see this is the acquisition time 2024-0309. Okay, so now I want to display this image in my map. So for that, we already know about that. Just use here map.add layer and call the image. So click to the run. So you can easily find out this type of tiles. You can see. So it's the default band combination, show this type of things. Further, we can also add the band combination and also display this image. But here you can see it's not fill up my study area. You can see sum of part is missing in here. In this part, sum of part is missing. So it means that this tiles is not fill up this type of region. So further, you check the another tiles or another scene or another image from here. Just click on here and you can see the feature. And if you just use here, just I copy this ID, second ID, and then check what happened for that. Just I copy and change the ID. Just change this ID, just change and run it. So now let's check what happened for that. Okay, this tiles is fully fill up my study area. Okay, you can see it's fully fill up my study area. Suppose now I want to use these tiles. Okay, you can see this tiles is fully fill up for my study area. So now just use here the cliff function. Okay, cliff function. And if you check it for cliff function only available for the image section. If you check it, suppose I will show you that. Just simply open the image and find out the image function. You can see the e.image. So just we use the e.image, this function, and we simply put our directory, mainly our id. Okay, this function will use in here for that, for image. And if you check other function, okay, further we'll also try to explain one by one all of function. So in this case we try to use the another function, this function called the you can see, where is it? Yeah, clip. You can see the clip function. Okay, so this function you have to use. So you can see clip an image to a geometry or feature. So in this case I already have the geometry, mainly Dhaka city boundary, and now I want to just clip, and you can see what is the argument. This argument is the geometry. Okay, just simply use it, clip, and then put the geometry name. So just I use here the dot clip, just use this function dot clip, and clip with your geometry. In this case my geometry is my shapefile or boundary, which is ROI, just on the code. So now we can got the image only for my boundary area, look like that. Okay, so now it show the default visualization, but I want to set the different types of band combination. Suppose true color or false color. Okay, different types of band combination. You can simply search on the Google. Suppose band combination. Suppose band combination of Landsat 8. Just simply search. So here you can see this is the link. Simply go to this link. You can find out the lot of information about the band combination. Landsat 8 band combination. So here you can see different types of band combination we're actually using here. So 432 basically red, green, and blue. Okay, it's one kind of band combination. Then we find out the natural color composite. Okay, natural color, what human eyes can see. Healthy vegetation is the green, unearthly flora is the brown, urban feature appear the white and gray. Also you can see this is the another band combination. So further you also try this type of band combination. So now suppose I want to apply this band combination in here. So how I can apply the band combination? So for that you can see in the layer, basically this is my image layer. Just click on here, and here you can see it show the default visualization. So I set here red, then green, and blue. Okay, and further stress 98%, and then clip. So now you can easily find out this type of band combination. Here you can see, so it's called the natural color. Okay, so natural color mainly what human eye can see, we find out in here. Suppose I want to apply the another one, just click on here. Suppose near infrared, then red and blue, just stressing suppose 98%. So stressing is one kind of visualization process. Okay, so using the stressing we can easily identify mainly better visualization when you apply the stressing. So basically stressing, you can see different types of label we find out in here. Stressing 1, 2, 3, 19%, 98%. So some map we find out that very good visualization for stressing 1, stressing 2, but default we are using the 98% all time to get the better visualization. Okay, so this is the another band combination. So in this band combination you can see we can easily find out this type of red color is one kind of vegetation. You find out it's a vegetation. Water body show as a black color or dark color, you can find out in here when I use this type of band combination. So you also read this article, then you also get the better idea how we can easily use the different types of band combination and how we can easily identify different types of feature from the satellite imagery. Okay, so now this band combination I want to import in my code editor. So in this case you can see there is no code for the band combination, but when I click on the import button, you can see the import. Just click on the import, it just add a new line of code. Just copy. Okay, and previous class we already know about that. After the e object, we are just need to put the visualization parameter. Okay, second argument or of map.addLayer function, visualization parameter. So this is the visualization parameter I just put in here, and then I put the layer name. Suppose I put the layer name is that false color composite, false color. Just click the run. So now it just set with my map. Okay, now we can find out. Suppose I want to create the another band combination, suppose true color, and I want to add as a layer. So how I can do it? Very easy. Just click on here again, and I set suppose red, then green and blue, staging 98%, and apply. So now you can get this type of natural color. So further again, just import. When I import, this visualization is imported in my code editor. So you can see when I just click on the import, it will be imported. This is a variable name. So now I just use it and then make another layer. So just write the code again. Just I write in here. So just I put here map.addLayer and then put here the image. Okay, after that I need to call the second variable for visualization parameter, mainly this variable. Just copy and paste here, then put the layer name. I put the layer name, suppose it's a natural color or true color, just on the code. Okay, so now you can see it's created another layer. We can easily visualize the two band combination at the same time. Okay, it's create the different layer, true color and false color. This is the false color, this is a true color band combination. You can easily get. Suppose I want to add the another one. Just click on here again, and I set it, suppose short wave infrared 1, then near infrared and blue, stressing sub 98% I keep. Further apply. So now it creates another band combination. Okay, it working. Just a minute. Okay, yeah, it's added. You can see. Suppose just I click on here, then I put here suppose these things, band 6, band 5 and band 2, stress is 1.8%, and further just apply and then import. You can see when I just click on the import, a new line of code will be added in here. Okay, 652. Further I want to add the layer. So for adding the layer, just I put here just paste here, and I put this layer variable name. Suppose just copy this variable and then paste here. Okay, you can put any name as the band combination. Suppose basically we are use it for agriculture. Just click run. So you can see create this 3 color band combination in here. So you find out, you can see this type of band combination in here. So further you also try to read these things, also try to apply for other band combination. Okay, and identify for different types of feature. So this is the single image. So in this case we are just work for the single image. Okay, so in the meantime, any question you can just ask me about the full code. Any problem or any confusion, just simply ask me, please. Any question, anyone?
Hi, yeah, I have a
Please,
question.
please.
The last line, you said that we have applied this band combination on the single image.
Yes.
So, like, can we take more than one image
Yes,
as well,
yes,
or
yes, yes.
we need to take one,
Yeah, so
only
now
one?
we talk about the this part, basically how we can easily create the composite. Okay, so different types. Suppose in this case I have total 4 images, and this 4 images, it's cover my 1 year. Okay, suppose 2024, 1st January to December, we find out the total 4 images. So I want to use all of images. Okay, I want to use all of images and create the composite. Okay, and it's very helpful basically when you work with big study area. So in this case, suppose for a small study area, one tiles we can easily find out it's fully fill up my study area. But when you work with suppose big study area, suppose you need the image for whole country boundary of Bangladesh. Suppose I need the composite, I need the satellite imagery, whole country boundary of Bangladesh. So then one tiles or one image is not fully fill up my whole country boundary of Bangladesh. Then we need to apply the composite. So we can create different types of composite. So in this time I talk about that how we can easily create the composite and how we can easily get this type of result. So let's go. So how I can create the composite? So let's go. When you work with composite, we have to use some function. We can use the different types of composite in Google Earth Engine. One is very popular, it's called that a median. So if you click on search on the median, you can see ee.image collection, it show the median. So basically median function we can only apply for the image collection. Suppose I have a image, suppose this variable is create the image. So in this case if I just use the median function in here, then it show that median is not a function, because median is only work for image collection. More than one image, call as image collection. Suppose I have a two images in my one variable, it's one kind of image collection. So always more than one image called as the image collection. Suppose I want to create this median composite and I want to use total 4 images. You can see it's here total four mainly total 4 element, mainly total 4 images. Okay, so I want to use total 4 images and create this median composite. So how it works? So basically you can see it reduce an image collection by calculating the median of all values at each pixel across the stack of all meshing band, and bands are meshed by name, mainly red b1 b2 b3, this type of name mesh. Okay, and calculate the median of all values at each pixel across the stack of all meshing bands. And how bands are meshed? By their name. Okay, so in this case suppose I want to use all of images and create the median composite. So how I can create? So for that, okay, just let me comment this type of thing. So this is the process for the single date. Okay, sometimes you also need to work with single date for a specific analysis. Sometimes you also need for the median composite. Suppose I want to need the image for the big study area, and this study area is not covered for a single tiles or single image is not covered. So then we have to use the median composite or mosaic composite. So let's go try to work with for that. Okay, just I comment this all of things. So now I create the median composite. Okay, so I want to use the total 4 images and create this median composite. So for that, just take a variable. Suppose I put the variable name is that final image. You can put any name as a variable, equal sign, and then call the filter date, because this variable is create the total 4 images. Okay, so just I put here the 4 images and it's my collection, it's my collection, 4 image collection. So that's why median function I can easily apply in here. Okay, just use here the median. Okay, and further just click to the run. So now I can see all of tiles mainly. Okay, as well as we also need to add the layer of it. So just use here map.add layer and call the final image. Click to the run. So now I can see all of tiles. Just make the median composite, and it easily cover my study area also. So when I applied for whole country boundary Bangladesh, then easily cover the whole country boundary of Bangladesh. Suppose let me show you the example. Just simply change my study area. Suppose I just import for whole country boundary of Bangladesh. Suppose I just import this shape file, and further I simply remove the previous one RY, Dhaka city, just remove it, and I put it RY. RY. So now if I run the code, it create the median composite which cover the whole study area of Bangladesh boundary. So let's check. So now you can see it cover, okay, and it create the median composite. You can see how much image we have to use in here. Total 49 images. Okay, we find out the 49 images. Okay, so now my whole study area is cover 49 images median composite. This is the result. So these things I want to just, because now I just apply the clip function. After applying the median, just use here the dot clip, clip, clip. So when I use the median, then this variable is not a collection. Suppose after applying the median, if I just use the median, further if you want to just check the data type, suppose I just print this final image, this variable just a single median composite image, not a collection. So check the result. You can see image computing. So it's not the image collection. Okay, it's just work as the image, median composite image when I use here the median. And when it just a median and it including all of band, all of missing band, create this type of median. Okay, b1, b2, b3, all of band. And when I get it's a image, I can easily apply a function, this function called the clip function, because we already this show the clip function is available only for the image. Okay, clip function is available only for the image section. So then I can easily apply, because I just use at the median, then it work as a median composite single image, not a collection. So that's why I can easily apply the clip function, clip with my study area, which is RY. So now run the. So I can get the result only for this boundary. Further same process, just add the band combination, also add the layer name, same. Suppose I just put here the band combination. Suppose red, or put here suppose shortwave infrared 1, then suppose near infrared and blue, stressing 98%. And further apply. Okay, so now you can easily get this type of composite, median composite, which covered the whole state area of Bangladesh boundary. So now we can easily use this image, and further you can easily make the different types of remote sensing analysis, such as land use, land cover, or if you want NDVI or anything for any remote sensing analysis, you can easily do it. Just simply import, then copy this variable name, just copy and just paste after the object name. Basically this is my object, final image, and put here this. So now it will be set. Okay, so further you can easily use the image to create the different types of remote sensing analysis, such as NDVI or land use, land cover, or anything we can do easily for the whole country boundary of Bangladesh. Okay, okay, anyone any question, you can ask me please. Okay, I hope there is no question. Okay, let me continue. Yeah. Okay, so this is the process for filtering, and the same process you also apply for other satellite imagery. For Landsat, mainly Landsat, you also try for surface reflectance. Okay, also try for, you can see the Landsat 9, Landsat 7, Landsat 5, Landsat 4. Okay, Landsat, all of are the same approach. So you also try. Further, if there's any problem, they also guide you. No problem. Okay. Okay, so now here you can see we write very long code to describe this type of function for filter bounds, filter metadata, filter date. Okay, so every new function I take the new variable. Always you can see filter metadata, I take the new variable, filter date, I take the new variable. But in this case, if you want, you can just take only for the one variable, and under this variable just add all of function. Okay, then our code will be shortest. So let's go how we can easily do it. I will show you that. So just I comment all of those. For first time, for understanding, I will write all of briefly. But when you write your own code, just do it very shortly. Suppose I just take one variable L8. Okay, L8. So now I want to use the L8 variable and all of function one by one. So just I filter it. Spaces doesn't matter. Spaces doesn't matter. So you can start from anywhere. There is no problem. Okay. Just I write in here, suppose dot filter bounds with my study area, which is ROI. Then put here, suppose dot filter metadata. Put here cloud cover. Less than 1. Then put here the filter date function. I put the date, suppose 2024, 1st January from 2024, December 31. Further, if I check, just use at the print function and use at the elect. So use the size function. So now after filtering the bounds, after the filtering the area, filtering the image metadata, or filtering the date, how much image I find out in this variable, it show me that. So just run the code. We find out the 49 image collection for whole country boundary of Bangladesh. Less than 1% image for whole country boundary of Bangladesh between this time period is available, 49% image. So now further I want to create the median composite. If you check, if I just use here the median, and now if I just run the code, it show a problem. It show that size is not a function. Okay, because when I use here the median, then this variable is not a collection, it's just a single median composite, and size function is only work for a collection, not image. Okay, so when I apply the median, then this variable just a single median composite. Okay, so now size function is not work. Size function is only work for a collection, maybe more than one image, then it will work. But after applying the median, this variable work as a single image. Okay, so that's why it show this type of problem. Size is not a function. So in this time, size is not work, because size is only work for collection. Okay, image collection or feature collection, size is work. But for the image, size is not work. Okay, so just I print, if you check it just on the code, so I can easily get the image. So this L8 is the image. So that's why image collection size function is not work, because if you check the size function in here, we find out the size function under the ee.image collection section. Okay, we already show this process. So if you check the size function is available in this section, ee.image collection section. So that's why it not work. Okay, so now it a image. So after create the median, so just it work as a single image. So image, for the image we can easily apply the clip function. We already know about that, clip. But if you don't use the median, suppose I simply remove the median and now run the code, it show a problem. You can see it show a problem. Okay, e.image collection filter bounds or clip is not a function. We found this a problem because clip is only work for image, not collection. So in this case, it work as a collection. Okay, if I don't use the median. So that's why I just use here the median, and when I use it median, then it work as a image, and further clip is easily work. So just run the code, clip is work. Okay, clip study area mainly ROI. Okay, your study area also mentioned in here. So further just display this image, just use our map dot add layer and call the L8, and we are just, suppose I use it visualization parameter which I already imported, and then put the layer name, suppose band combination, you can put any name, just run the code. So now it loaded, you can see, you can easily find out this result. Okay, so this is the easy way we can do only for these things, but first time for explanation all of function, I write all of details one by one for your understanding. Okay, but now I hope we can easily get this idea how we can easily filter. Okay, just we need only for this code, short code, filter bound, filter metadata, filter date, and median and clip, and then we can easily display this type of imagery. And when you work with the single date image, just try to apply this process to get the single date image. Just copy the id and then visualize the single date image. So this is the process to create the composite and also create the single date imagery. So further class we also discuss about the another composite such as mosaic or other things. Step by step I will try to explore all of those things, then you can get the idea. So now we find out this type of imagery. So now how I can export this.
Sorry, excuse me.
Please.
Can you scroll up? Can you scroll up a bit to the last part?
Yeah.
No, up a bit. Up
Yeah, this one.
to number, I think number 20, number 17. Line 17, please.
Line. How much?
17. Up. Yeah. I just want to see the last command on
Yeah.
line 12.
Yeah, you can see.
Line 12, please. Okay. Okay, thank you.
Yeah. So now these are main code for filtering image, but first time I try to explain all of those step by step, so that's why I write the briefly. I write the code look like this way. Okay. So now how I can export this type of satellite imagery, and exporting basically is the same. Okay, when you create any kinds of map, further we can easily always we try to apply the same process, and further we try to export this type of map easily. So before we also discuss about that another topic, suppose I give the another example for the modis. So now we also try for the other image collection for Landsat, the same process also try to apply. So now we talk about the modis. So modis basically find out the lot of product, different data set, we find out the lot of product. So this type of product you also try. So in this time I just show you only for the one, but using this process you also try to apply for any other modis product. You can easily filter for any remotely sensed data from modis. So you can see it provides a lot of information. This is the terra land surface temperature information, LST 8-day global, terra vegetation index is 60-day global. Also you can see terra vegetation is 60-day global, 1 kilometer resolution data. So it's provided a lot of data. You can see, you can easily find out from here. Okay, so now we can easily work if you just learn only for the one data set. Further just apply the same approach any data set in here for the modis. So let's check, I show you the one example. Suppose just I want to use this data. Suppose I want to work for this data. Suppose this data I want to use. Suppose you can see this the terra vegetation index is 60-day global, 250-meter resolution. So this data I want to use, and further I want to create the map. So this same process you can also apply for others data set which are available in here. Just I click on here. So now you can get all of information about this data set. So here you can see we can easily find out the different types of information. Basically data set availability date, this data set is available between this time period. Okay, and this is the id, mainly snippet id of this data set. So we are just use this id and we can easily import our data set in the code editor. And basically this data set provide you with the two information, ndvi and evi, basically normalized difference vegetation index and enhanced vegetation index. We can easily find out in here. And if you check the description, basically how they create this data set, and this data set is very popular because you can see this data set is already masked all of unnecessary pixel such as water, cloud, heavy aerosol or carbo or cloud shadow already masked. So that's why when you're using this data, we find out very neat and clean ndvi map. Okay, so we try to use the data and further we create this ndvi map for any specific boundary. So let's go. First of all, this snippet, mainly this id, just copy in your code editor. Just copy this and open a new code editor. And paste here. Okay, so just we simply paste, and it's also image collection. You can see this is the modis and this is the id, basically this id, product id of modis. So now these things we try to import in a variable. You can put any name as a variable. I put the name, suppose modis. So now these things I simply store it in this variable. You can put any name as a variable. And if you check this image collection have two band. If you check the band name, basically ndvi and evi. Suppose I want to work only for this single band of ndvi I want to use. Okay, so for that just use a function dot select function for selecting a specific band. I want to select suppose ndvi. Okay, so from this image collection I just select only for the single band, and further just I put another function filter date for a specific time period. Suppose I want to create the map in year of 2000, suppose 24, 1st January from 2024 December 31. So this is my time period. So in this case, if I just try to check how much image is available for 1 year, modis, just use the size function and click the run. So now it's computing. We find out the total 23. Okay, 23 images is available, and this 23 images we find out that 16 day global, basically 23 uh, 23 multiply with 16, we find out that almost 1 year, so it covered the 1 year. So for the 1 year we find out that 23 images. Okay, so now I want to use it and make the map. So if you want, just use here map dot add layer and use here the modis and just run the code. So now it show the global ndvi map. We can easily find out in here. You can see it display the global ndvi map in here. Without color we find out this type of map. So now I want to add the color. So for adding the color, if you just I copy their default color code from here. You can see they already have default color code. Just I copy and then paste here. In color code, basically they are create a dictionary. Okay, in this dictionary they are put here the mainly keyword and key value, and also put the different types of hexa color code. Okay, so I use the default, I want to use it. So just copy this variable name and paste after the object name. Basically always we put here the visualization parameter. So basically this is my visualization parameter. Okay, just run the code. So you find out this type of ndvi map for the globally display this type of ndvi map. So now further you can easily do it for a specific boundary or a specific country. We can easily find out from here. So now we find out for the global ndvi map in year of 2024 for the whole year. Okay, but I don't need for the whole year ndvi map, so I need it for a specific boundary. So for that, just need to import a shape file. Suppose I just import the shape file from, just I simply use this data, USD data. We already know about that. International country boundary polygon. Just import. And then take a variable, suppose RY, and then filter. Okay, previous class I already discussed about that, how we can easily filter and get the boundary. So now Bangladesh, I just simply take the Bangladesh boundary, and I want to need the data only for the Bangladesh boundary. So now if I just clip, you can see here, if I just take a variable, suppose ndvi bd, and I just call the modis, because it is this full map is stored in the modis, and use that the clip function, and just use that ROI, because ROI is my shape file. You can say ROI is stored in my shape file. So now further I want to add the layer, just copy and paste here. I want to add the layer only for the Bangladesh boundary. So now we can find out a problem. Anyone can guess it? What is the problem in here in this code?
Yeah, because it's a collection of images. We need
Yes.
to calculate the median.
Yes. So this is the collection. We find out the 23 image collection. So when you need to work with clip, we need to convert it as an image. Okay. So now we need to reduce this image collection. So basically for NDVI, we are just use here the average NDVI. It calculate the average. Suppose if you check what is the mean function, just click on here and check it. Suppose mean, and find out the mean function. So you can see e.image collection. So I have a collection, total 23 image collection. So I need to apply the mean. When I apply the mean, what happened? It reduced an image collection by calculating the mean of all values at the each pixel across the stack of all missing bands. In this time, missing bands of NDVI. Okay. So now we try to use the mean in our image collection. That will work. So let's go and try to do it. So for that, just I take a variable, suppose mean NDVI. Okay, and I call the modis, because it is stored at 23 image collection. Just I copy the modis and use here, and then simply use at the mean. Okay, mean, and when it will be mean, then it just a single average NDVI. Okay, these things I can simply clip with my study area, which is ROI. So now further I simply copy and then display these things in here. Okay, so this line is not need, just anymore, just run the code. So now we can get the result only for this country boundary of Bangladesh, but it not focus. So let's try to focus. Just use here map dot center object is ROI, zoom level suppose 10. So now you can easily get this NDVI map in year of 2024 in Bangladesh. So any country boundary you can easily do it, because USDOS is already stored all of country boundary shapefile. Suppose I need this result for, suppose, Saudi Arabia. Just write the name and click to the run. So now you can easily find out this Saudi Arabia NDVI map in year of 2024. Okay, green is indicating about the vegetation. Suppose I need for this map another country, so just write the country name. You can easily get it. Suppose I need this country for Colombia. Click to the run. So now you can easily get this NDVI map in year of 2024 in Colombia. Okay, just simply write the country name. We can easily get this type of information from here. So any country, just write the name. We can easily get this map, because this table is stored the all of international country boundary polygon. Or if you want, you can simply draw your study area. Suppose just draw the study area. Suppose I put the draw the study area. Suppose I need this map for this boundary. For this boundary, I need this map. So it is the geometry. Okay, so just I clip with my geometry. Just put here the geometry. So now I can get the result for my geometry, which I put in here. So you can, so we can get this type of map of NDVI for this place. Or any boundary, you can simply import in the asset tab any shape file and further work with that. Okay, so in this case, suppose I just keep for, okay, we can also do it. Suppose you can just simply import your shape file, or also import any specific, you can digitize your study area or draw the rectangle or make the polygon, and you can easily do it. Okay, we find out this type of NDVI map, but this NDVI map have a problem. This problem is that if you just click on the inspector tab and click on this map pixel, you can see find out this type of pixel value 4151.34. If I just click on the water body, we find out the negative 830. But NDVI range, if you check the NDVI range, so we find out that NDVI range always positive to negative. Okay, mainly high. If you just click on here, you can get the more information about that NDVI. So you can see NDVI values range from positive 1 to negative 1, and areas of barren rock, sand or snow usually show very low NDVI values, for example 0.1 or less. Sparse vegetation such as shrub or grassland or sensing result with moderate NDVI value approximately 0.2 0.5. Okay, and high NDVI values 0.6 to 0.9. Okay, for a high NDVI values, but in this case it show me this type of value, you can see. So this result we find out, but this result is not reprojected. So now how I can reproject it? So all lot of time when you work with MODIS data, this type of things we need to get the proper pixel value, we need to reproject it. So if when you work with data set, first of all you can just check the bands, and if you find out any scale value, suppose you can see it show the scale value, so it means that further to get the better pixel value or accurate pixel value, you must need to use this scale for any data set. So when you check it, this data set available the scale value, you must use it, this scale value, to get that better or accurate pixel. Okay, or reprojected the pixel value, we must use this scale value. Okay, for any data set. So for LST or NDVI or any data set, if you get this type of scale value, then simply use the scale value, and further we can easily reproject the scale value. So now how I can reproject it, this scale value? So in this case, this scale value you need to multiply. You need to multiply with all of images. Basically, total 23 images. I need to multiply with this scale factor, mainly 0.001. Then I find out that accurate pixel of NDVI. So now 23 images I need to multiply with this same value. So at the same time I want to do all of those. So that's why we need to use the concept of function. So previous class I already discussed about that, how we can easily create the function and how we can easily use the function to reuse our code. So in this case, same concept we also use. In this time, what is my argument? My argument is that I need to multiply this value with all of images, 23 images. Okay, so let's go try to create a function. So let's go for creating a function. Okay, right in here. Suppose just take a variable name. I put the variable name, suppose scaled NDVI. You can put any name as a variable, and then put the function keyword. Okay, in this function keyword, I just take the element. We already know about the element, so just I put the element name, suppose img, and then put my curly bracket. In this curly bracket, I put my argument, what I need. My argument is that this image or this element I need to multiply with my scale factor. So just I return this image multiply with my scale factor, which is 0.001. Okay, basically this scale 340 0.00 and also another 0.1. So this value I need to multiply. So I take a one element and this element I return and multiply with this scale factor, scale value. But in this case, I just take only for the one element, but I have also rest of 22 element for this case. So what can I do for that? So for that, you just use a function, this function called the copy properties. So mainly this function copy the properties after multiply. Okay, suppose for it just copy the properties after multiply and store it the element, and further these properties I apply between this time period, because between this time period I find out total 23 images. Okay, so and this time period we define as a system time start to system time end. So this is my function. Okay, so I again explain this function, how I can create. Just take a variable name, function keyword, element name, you can put any name as an element, then put the curly bracket. Okay, in this curly bracket what is my argument? So my argument is that I want to multiply my scale factor with this element, but I just multiply only for the one element, but I have also rest of 22 element. So for that I just use a function copy properties after multiply this element, and these things I apply system time start to system time end, which is indicating this time, and this time I find out total 23 images. Okay, so now it multiply all of images. So now this is my function, and this function I need to connect with my image collection. If you check this image collection, basically this code and this function code which I write in here, there is no connecting. Okay, so just I need to make a connection between the function and collection. So for that I just take a variable, suppose I put the variable name is that, or if you want just you can call the collection, just simply call the collection modis, copy the variable name, and then connecting, just paste here, and use here the dot map function for connecting this function and close the parenthesis. Okay, so now this is my collection and this is my function I connecting, and now this is my variable, it is stored the after multiply all of images stored in this variable. Okay, so now further I use it and calculate suppose mean, because this variable is stored the reprojected because I already multiply and stored it in this variable, and then just run the code. Okay, where is the map? Okay, let me just zoom on the center of geometry because we work for the geometry. So just use here geometry. So just it show as a white color. Okay, because we also need to change the visualization parameter in here. So if I just default +1 to suppose -1, just a default and run the code. So we find out this type of visualization, but it's also not good. Okay, so now we try to stressing, because we are also use the stressing to get the better visualization. Just stress the data, it show me the value. Just I put the mean range and put in the mean and copy the max range and paste here. So now run the code. So now you find out this type of map. Okay, so if you want, I want to show suppose my own color. Okay, this type of color I not use, just I copy remove all of color. Suppose I put the low NDVI, show as a blue color. Greater than I want to show suppose white color. and greater than I underscore suppose green color. So now it creates this 3 color band combination and display the result. Or you can put any color, okay, for different color you can also use in here, there is no problem. So and I can see we can easily find out this is the water body show as a blue color and vegetation or dense vegetation show as a green color. Okay, if you check the pixel value, just click on the Sphere tab and click on your map, we find out negative 0.8. Just click on here, we find out the 0.8. It means that it's a dense vegetation. Negative pixel value indicating about the water body. Okay, so it's one kind of NDVI map we generate from the MODIS. So this result I need for the country boundary. So just I clip, just I simply change here, you can see the clip with my ROI to run the code. So now we can get the result, and I just put here suppose ROI focus. So now I can get the result for Colombia. Okay, so if you just get this type of map from here, and then further you can simply export this type of map as a GeoTIFF file format, and these things I will try to explain basically how we can easily use the ArcMap to generate the research paper map, okay, or your presentation, how we can easily generate this thing, also try to explain. So now in this code, anyone any question for generating this type of map, you can ask me please. Okay, I hope there is no question. And this same process you also apply for any other.
Actually, I do have a question. Yeah.
Please.
On the part of making the NDVI map,
Yeah.
can I make it like the difference? Can I have the difference between maybe from the initial date to the final date, so that I see if there is a vegetation change?
Yes. So
it
these
changes?
things we discussed in our last class. You can see in the change detection part, we try to complete this type of things. We can see the NDVI change detection using Google Earth Engine or land use network change detection. So it will be completed, no problem. Yeah, we also discussed.
Okay, thank you.
Yeah. Okay, so this is the process to work with MODIS data. So further, you can see MODIS have lot of data. Okay, so you also try for your own boundary. Suppose you can see the thermal anomalies, fire daily data. So we can easily identify for fire detection area using this data. Okay, so also you can see the leaf area index data. Okay, evapotranspiration data. Also you can see the net evaporation gap fill data. Okay, the gross primary productivity data. So different types net net primary production data. So LST data. So further you also try to create the map using this type of data. Okay, the same process, you just apply and you can easily create this type of map. And when you work with then you also try to check their scale is available or not. Okay, if their scale is available, you must need to multiply. Okay, otherwise we don't find out the accurate pixel. Okay, so if you check, suppose you work with for another data, suppose this is the LST data for 8-day global, just click on here. So here you can see this is the scale is available, okay, for this data. So you must use the scale value to get the accurate pixel of LST, otherwise you can find out the very long value. So you also check if the scale is available, must use it to get that proper or reprojected the scale value. Okay,